All right, homework 38, we're switching into some probability type things, and the first thing we're going to talk about are some sequences, either an arithmetic sequence or a geometric sequence. An arithmetic sequence is one where you're always adding or subtracting the same value to each term. So if we look at our formula here, we have a sub n equals 31 plus 3 times n minus 1, n, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and goes on and on and on forever. We are finding the first 4 terms of our sequence. So a sub 1 would be 31 plus 3 times 1 minus 1. If I figure that out, 1 minus 1 is going to be 0, so I'm going to have 31 plus 3 times 0 is 0. And so 31 is going to be the first term in my arithmetic sequence, this number right here, 31. If I do a sub 2, I'm going to do 31 plus 3 times 2 minus 1. Well, 2 minus 1 is 1. So I'm going to end up with 31 plus 3 times 1, which is 3, and I get 34. A sub 3 means I'm going to have 31 plus 3 times 3 minus 1. 3 minus 1 is 2. So I'm going to have 31 plus 3 times 2, which is 6, which gives me 37. And then a sub 4 is 31 plus 3 times 4 minus 1. 4 minus 1 is 3, so I'm going to have 31 plus 3 times 3 is 9. 31 plus 9 is 40. You can see what happened is my starting value was the 31. The 3 here is what I'm adding each time. 31 plus 3 is 34. 34 plus 3 is 37. 37 plus 3 is 40. So each time I added 3 to get to the next term in my sequence. So first 4 terms, 31, 34, 37, and 40. So number 2, finding the first 4 terms of my sequence. So a sub 1, a sub 2, a sub 3, and a sub 4. 36 minus 4 times 1 minus 1. 36 minus 4 times 2 minus 1. 36 minus 4 times 3 minus 1. And 36 minus 4 times 4 minus 1. Plugging in my values for n. So here, 4 minus 1 is going to be 0. 2 minus 1 is going to be 1. 3 minus 1 is going to be 2. 4 minus 1 is going to be 3. So here I'm going to have 36 minus 4 times 0, so minus 0. Here I'm going to have 36 minus 4 times 1, which is 4. Here I'm going to have 36 minus 4 times 2, which is 8. Here I'm going to have 36 minus 4 times 3, which is 12. So my answers, 36 minus 0 is 36. 36 minus 4 would be 32. 36 minus 8 would be 28. 36 minus 12 would be 24. Each time I'm subtracting 4, I started with 36. I subtracted 4 from each one of them, so 32, 28, and 24 gives me my first 4 terms of my arithmetic sequence. So here a sub n equals 51 plus n minus 1 times 8. So a sub 1, 2, 3, and 4 are what we're going to find. 51 plus 1 minus 1 times 8. 51 plus 2 minus 1 times 8. 51 plus 3 minus 1 times 8. And 51 plus 4 minus 1 times 8. So again, when we simplify, 1 minus 1 is going to be 0. 2 minus 1 is going to be 1. 3 minus 1 is going to be 2. And 4 minus 1 is going to be 3. So 51 plus 0 times 8 is 0. Gives me 51. 51 plus 1 times 8 is 8. gives me 59. 51 plus 2 times 8 is 16, which gives me 67. And last one, 51 plus 3 times 8 is 24, which gives me 75. So on this arithmetic sequence, we added 8, and added 8 again. So arithmetic sequence, you're either adding or subtracting the same number from each of my terms in my sequence. Four, 5, and 6, we are finding the first terms of a geometric sequence. And so again, we have a sub n equals 3 times 4 to the n minus 1 power, n being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. We're doing just the first 4 terms. So a sub 1 would be 3 times 4 to the 1 minus 1 power, which gives me 3 times 4 to the 0 power. Anything to the 0 power always equal to 1. So 3 times 1 would just give me 3 for the first term of my sequence. A sub 2 would be 3 times 4 to the 2 minus 1. Well, 2 minus 1 is 1, so I'd have 3 times 4 to the first. 4 to the first is 4. 3 times 4, going to give me 12. A sub 3, 3 times 4 to the 3 minus 1. Well, that would give me 3 times 4 to the second power. 3 minus 1 is squared. 4 squared would be 16. 16 times 3, 48. And then a sub 4 would be 3 times 4 to the 4 minus 3 power. So 3 times 4, 4 minus 3. 4 minus 1 power, I'm trying to put the 3 in there. 4 minus 1 power. 4 minus 1 would be 3. 4 to the third is 64. 64 times 3, 192. So what happened is if I took 3 times 4, I would get 12. 12 times 4 is 48. 48 times 4 would be 192. So I started off with 3. I multiplied by 4 each time. Times 4, times 4, times 4, times 4. If we look at the next one. Again, I'm doing my first 4 terms. So A1, A sub 2, A sub 3, A sub 4. So I'm going to have negative 5 times 2 to the 1 minus 1 power. Negative 5 times 2, 2 minus 1 power. Negative 5 times 2 to the 3 minus 1 power. And negative 5 times 2 to the 4 minus 1 power. So this is going to be 2 to the 0, 2 to the first, 2 to the second, 2 to the third. So negative 5 times 2 to the 0 power is 1, gives me negative 5. Negative 5 times 2 to the first power is 2, negative 10. Negative 5 times 2, oops, I didn't want to write the 2 there because I want to figure that out. Negative 5 times 2 to the second power would be 4, so negative 20. And then negative 5 times 2 to the third power would be 8, so negative 40. So we started with negative 5, we went times 2, which gave us negative 10, times 2, which is negative 20, times 2, which is negative 40. There is our geometric sequence. We multiplied by 2 each time. Number 6. Same kind of thing. We're doing our first 4 terms of our geometric sequence. So a sub 1, a sub 2, a sub 3, and a sub 4. We're going to have 4 times negative 5 to the 1 minus 1 power. 4 times negative 5 to the 2 minus 1 power. 4 times negative 5 to the 3 minus 1 power. And 4 times negative 5 to the 4 minus 1 power. So 1 minus 1 would give me 0 power. 2 minus 1 is the first power. 3 minus 1 is the second power. 4 minus 1 is the third power. So 4 times negative 5 to the 0 power is 1, gives me 4. 4 times negative 5 to the first power would be negative 5, so I get negative 20. 4 times negative 5 squared. Negative 5 times negative 5 is a positive 25. 4 times 25 is 100. 4 times negative 5 to the third power. Negative 5 times negative 5 times negative 5 is negative 125. 4 times negative 125 is negative 500. So again, our starting value was 4. We took it times a negative 5, which gave us negative 20. Negative 20 times negative 5 is a positive 100. 100 times negative 5, negative 500. So each time there we multiplied by a negative 5, and so our signs changed when we multiplied. All right, 7, 8, and 9, we are finding the next terms in my arithmetic sequence. If I have an arithmetic sequence, it means I had to add or subtract the same number to each of my terms to get the next term. So if I have negative 7, negative 4, and negative 1, I'm thinking about negative 7 plus or minus something to give me negative 4. Well, negative 7 plus 3 would give me negative 4. Negative 4 plus 3 gives me negative 1. So for my next term, I'm going to take negative 1 and add 3. Negative 1 plus 3 would give me 2. For my next term, I'm going to take 2 and add 3, gives me positive 5. So 2 and 5 would be the next two terms in my arithmetic sequence. So number 8, same kind of thing. I have negative 15, negative 11, and negative 7. To get from negative 15 to negative 11, I'd have to add 4. From negative 11 to negative 7, again I add 4. So to find my next two terms, I'm going to add 4. Negative 7 plus 4 would be negative 3. Negative 3 plus 4 would be positive 1. So negative 3, excuse me, and positive 1 would be the next two terms in my arithmetic sequence. Number 9, same kind of thing there. I have negative 14, negative 19, and negative 24. To get from negative 14 to negative 19, I'm subtracting 5. To get from negative 19 to negative 24, again I subtract 5. So to find my next two terms, I'm going to minus 5. Negative 24 minus 5 would give me negative 29. Subtracting 5. Negative 25, negative 29 minus 5 would be negative 34. So negative 29 and negative 34, the next two terms in my arithmetic sequence. So if I have an arithmetic sequence, I'm looking, am I adding the same number or subtracting the same number from each term, and then just continuing my pattern. 10, 11, and 12, we are finding the next terms of our geometric sequence. For a geometric sequence, we are either multiplying or dividing by the same number. So if I have negative 7, negative 14, and negative 28, to get from negative 7 to negative 14, I times by 2. Negative 14 to negative 28, again I times by 2. So to find my next two terms, I'm going to times 2 and times 2 again. Just to make it a little easier, I'm going to grab my calculator, if I can find my calculator. No, let's use this one. Don't know where I put my other one. So, negative 28 times 2 would give me negative 56. And if I times that by 2, I get negative 112. So negative 56 and negative 112, the next two terms in that geometric sequence. For number 11, I have 10, then negative 40, then positive 160. To get from 10 to negative 40, I would have to multiply by a negative 4. If I take negative 40 times another negative 4, negative times a negative makes that a positive 160. So again, for my next two terms, I'm going to multiply by negative 4. So 160 times negative 4 would give me negative 640. If I times by negative 4 again, I get a positive 2,560. So negative 640 and positive 2,560 would be the next two terms in my geometric sequence. On number 12, you can see our values are getting smaller instead of bigger. So I'm either multiplying by a fraction or I'm just thinking of it as dividing. If I take 243 and divide it by 3, I get 81. So I'm dividing by 3 each time, or multiplying by 1/3 would be the same thing. So if I have negative 243, negative 81, negative 27, and I want to find my next two terms. If I divide by 3, I get negative 81. Negative 81 divided by 3 is negative 27. Negative 27 divided by 3 would be negative 9. Negative 9 divided by 3 would be negative 3. So negative 9 and negative 3 are the next two terms in my sequence. So a geometric sequence, you're either multiplying or dividing by the same number. Introduction to the counting principle. The counting principle says if I have so many of each kind of thing that I can multiply the combinations together in order to figure out how many outfits I have. If I think about it this way, I have 2 shirts. Maybe one's red and one's blue. And I have 3 pairs of pants. I've got my jeans, I've got my khaki pants, and heck, maybe I have a pair of leggings. So, I can either wear my red shirt with my jeans, my red shirt with my khaki pants, or my red shirt with my leggings. I could wear my blue shirt with my jeans, my blue shirt with my khaki pants, or my blue shirt with my leggings. I've got 6 possible ways of doing that because I had 2 ways to do my shirt, 3 ways to do my pants. 2 times 3 gives me 6 different outfits that I can make. So fundamental counting principle just says I take the number of ways I can do the first thing times the number of ways I can do the second thing, and I get the total number of ways I could do that. Same thing if I have a longer list. Jane is ordering an ice cream dessert. She must order a size, a flavor of ice cream, and a topping. There are 3 sizes, 1 flavor, and 3 toppings. How many different ice cream desserts could she order? Well, 3 times 1 times 3 would be 9 different ways I could make my ice cream dessert. Lunch special at Bill's restaurant is a sandwich and a drink. There are 5 kinds of sandwiches and 2 drinks. How many lunch specials are possible? There would be 10 different ways I could do that if I have 5 sandwiches and 2 drinks. So, counting principle, I take the number of ways from each choice, I multiply it together, that tells me the total number of ways I could do it. So 16, 17, and 18 really are the same thing. I'm using my counting principle. This time they just give me a table of values, but I'm going to make a committee of 5 people. I'm going to have faculty member. I've got 1, 2, 3, 4 of them to choose from. I'm going to have a male student. I have 1, 2, 3, 4 of those to choose from. I'm going to have a female student. I've got 1, 2, 3, 4 of those to choose from. I'm going to have a parent. I've got 1, 2, 3, 4, 5 parents to choose from. And I'm going to have a school board member. I only have 2 of those to choose from. So how many different ways can I make my 5-person committee? I'm going to take 4 times 4 times 4 times 5 times 2. I'm going to have 640 possible committees that I could make for my combination of people here. So number 17, when ordering the kids' lunch at Burger University, the customer must choose a size, whether or not to have cheese, a side order, and a type of fruit drink. So, 3 possible sizes. My cheese selection, either with cheese or without cheese, 2 possible selections. Side orders, fries or onion rings, 2 possible selections. Fruit drink, orange or grape, 2 possible selections. So I'm going to take 3 times 2 times 2 times 2, and I'm going to have 24 possible lunch combinations that I could have. Number 18 says, suppose that each license plate in a certain state has 6 characters with repeats allowed. My first character is one of the digits 1, 2, or 3. So I have 3 choices for that. The second character is one of the 26 letters. So I have 26 choices for that. My third character, again, is one of the 26 letters. So again, I have 26 choices. My fourth one is one of the digits 0 through 9. There are 10 digits. So 10 choices there. My fifth character, again, is one of the digits 0 through 9, so 10 choices there. My sixth character is one of the 10 digits 0 through 9, so 10 choices there. So 3 times 26 times 26 times 10 times 10 times 10. I can have 2,028,000 different license plates as long as I repeat the values. So fundamental counting principle, I just take each of my number of choices for each of my options, multiply them together. That's going to give me my total number of possibilities. All right, so a permutation and a combination. This is read, the permutation of 9 things taken 3 at a time. So I might have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to use 3 of my numbers, and I want to find out how many different arrangements I can have. And a permutation, the order is important. 1, 2, 3 is not the same thing as 3, 2, 1. For a combination, the order doesn't make a difference. It's like having a group. The group 1, 2, 3 is the same thing as the group 3, 2, 1. So permutations, you have a lot more options because the order of my arrangement makes a difference, whereas a combination, you think of it as a group, you're not going to have as many choices. When I do a permutation of n things taken r at a time, you take n factorial over n minus r factorial. For a combination of nr, we take n factorial divided by n minus r factorial times r factorial. So we get rid of all the extra ones where they're exact same group of things. Now factorial means you take that number, like 9, times every number below it. So 9, 8, 7, 6, 5, 4, 3, 2, 1, till you get down to 1. So if I am going to evaluate the permutation of 9 things taken 3 at a time, I'm going to do 9 factorial over 9 minus 3 factorial. 9 minus 3 would give me 6 factorial. So if I think about this the long way, 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Notice, everything below 6 factorial is just going to cancel out. So I'm going to take 9 times 8 times 7. 9 times 8 times 7 is 504. For my combination, if I have 11, 4, I have 11 objects, I'm going to take 4 at a time. I'm going to do 11 factorial over 11 minus 4 factorial times 4 factorial. So, 11 minus 4 would be 7 factorial. 7, 8, 9, 10, 11. So, when I think about this, 11 factorial would be 11 times 10 times 9 times 8 times 7 factorial, because it's 7, 6, 5, 4, 3, 2, 1. Since I already have a 7 factorial, I'll be able to cancel those out. Then I have the 4 factorial. 4 times 3 times 2 times 1. So I can do some reducing. I have an 8 and I have a 4 times a 2. Well, 8 and 4 times 2 are both 8, so I can cancel that out. 3 and 9. 3 goes into 9 3 times. So I can take 11 times 10 times 3. 11 times 10 times 3 gives me 330. Now, just for purposes of checking, not that I think that you should use your calculator to figure these out, you do have a permutation and a combination button on your calculator. It happens to be right next to the x to the negative 1 underneath your alpha key. You see in yellow is NPR, the key says NCR. So if I were doing this permutation, I'm going to put 9, shift, the NCR key, but it really puts the P in there because the shift gives me the one above it. So 9P3, if I hit equals, I get 504. If I'm doing the combination, 11, just the NCR key, which gives you the C on your screen. So 11C4 gives me 330. So do it on your paper, but if you want to double check it on your calculator, you do have the combination, which is the regular key, and then the permutation where you have to hit the shift button first. So put the number in. If you want the permutation, shift in your combination key. If you're doing the combination, the 11 and then the key. Number 20 then. They switched them around. So I am going to have 9 things taken 4 at a time. I'm doing a combination, which means the order doesn't matter. And so I would do 9 factorial over 9 minus 4 factorial divided by that extra 4 factorial, since I'm going to have fewer choices. This would make this 5 factorial. So 9 times 8 times 7 times 6 times 5 factorial. 5 factorial times 4 times 3 times 2 times 1. So that will cancel. 3 times 2 is 6. 4 goes into 8 2 times. So 9 times 2 times 7. 9 times 2 times 7 gives me 126. So 126 would be my first answer there for my combination of 11 or 9 things taken 4 at a time. For 8P3, a permutation of 8 things taken 3 at a time. I'm going to have 8 factorial over 8 minus 3 factorial. So I'm going to have 8 times 7 times 6 times, this would be 5 factorial, 5 factorial on the bottom. My 5 factorial is going to cancel out. So 8 times 7 times 6 gives me 336 permutations. Number 21. 4P3. I'm doing a permutation, 4 factorial over 4 minus 3 factorial then, which is 1. So 4, 3, 2, 1 factorial divided by 1 factorial. 12 times 2 gives me 24. Possible ways to have that. And the last one, 12C4, I'm going to have 12 factorial over 12 minus 4 factorial times 4 factorial. 12 minus 4 would be 8. So 12, 11, 10, 9, 8 factorial. I've got 8 factorial on the bottom, and then I've got 4 factorial, so 4 times 3 times 2 times 1. 8 factorial is going to cancel out. 4 times 3 is 12. 2 goes into 10 5 times. So if I take 11 times 5 times 9, I get 495. So for a permutation, you're going to have more choices because the order is important. Combination, you divide by that extra to divide out those extra possibilities, because 1, 2, 3 is the same group as 3, 2, 1. And so you have fewer choices there. And so those are your formulas. On the next ones, we will be doing some word problems doing those things. Okay, so we are now going to do some word problems using permutations and combinations. Again, my formula for my permutation is I'm taking n factorial divided by n minus r factorial. For my combination, I'm going to take n factorial divided by n minus r factorial. But since the group 1, 2, 3 is the same as the group 3, 2, 1, I'm also going to divide that by r factorial to get rid of the repeats. And so if the order is taken into consideration, it's a permutation. If the order is not taken into consideration, it's a combination. So, wants to know, for my permutation, how many ways there are choosing 3 letters from the letters A, B, C, D? 4 choices. So I have 4 objects. I'm going to take 3 of them at a time, and I'm going to figure out my permutation. So 4 factorial over 4 minus 3 factorial, which is 1 factorial. 4, 3, 2, 1 over 1. 12 times 2 gives me 24 different arrangements that I could have. A, B, C would be different than C, B, A. Now, if the order is not taken into consideration, I'm doing a combination of 4 things, taking 3 at a time. So I'm going to have 4 factorial over 4 minus 3 factorial times 3 factorial. So I would have 4 times 3 factorial, since I have the bigger one that I want to use, over 1 factorial. The 3 factorial is going to cancel out, so I'm going to have 4 over 1. I only have 4 possible combinations instead of 24 possible permutations. So if I have A, B, C, D, and I'm taking 3 of them at a time, here A, B, C is different from C, B, A. That's 2 different ways. But here A, B, C is the same thing as C, B, A. It's the same group. That only counts as 1 arrangement. So it narrows down and cuts out the number of possibilities. I have 24 permutations, but I only have 4 combinations that I could make. So, how many ways are there of choosing 2 objects without replacement from 4 objects? A pencil, eraser, desk, and a chair. So, if the order is relevant, if pencil, eraser is different from eraser, pencil, then I have 4 objects taken 2 at a time. 4 factorial over 4 minus 2 factorial, which is 2 factorial. So 4 times 3 times 2 factorial over 2 factorial gives me 12 different ways of arranging my 2 objects from those 4 selections. Combination of 4 things taken 2 at a time where my order is not relevant. If I grab the pencil first and then the eraser, it's the same group as having the eraser first and then the pencil. So I'm going to have 4 factorial over 4 minus 2 factorial times 2 factorial. So I'm going to have 4 times 3 times 2 factorial over 2 factorial and 2 factorial. So here that's going to cancel. 2 goes into 4 2 times. 2 times 3 is 6. So I have 12 permutations but only 6 combinations. And one last one on here. It says how many ways if they are choosing 2 objects without replacement from the 5 objects, pencil, eraser, desk, chair, and lamp, if the order matters. So if the order matters, I'm going to do a permutation of 5 objects taken 2 at a time. 5 factorial over 5 minus 2 factorial, which is 3 factorial. So 5 times 4 times 3 factorial over 3 factorial. 5 times 4 is 20. I have 20 different permutations. Pencil eraser is different from eraser pencil. Pencil desk is different than desk pencil, and so forth. If the order does not matter, 5 objects taken 2 at a time doing a combination, I would have 5 factorial over 5 minus 2 factorial times 2 factorial. So that would be 3 factorial. So 5, 4, 3 factorial, 3 factorial, and then 2, 1. That would cancel. 2 goes into 4 2 times. I'm only going to have 10 combinations instead of the 20 permutations. So permutation, the order is important. If I switch the order, it's a different permutation. Combination, the order doesn't matter. If I switch the order, it's still the same grouping, still the same group, the same combination.